How about it? Problem of the day time. Let's see what we've got going here. Woo! We've had some long problems this week, haven't we, folks? A little bit of reading, but that's all right. If a rectangle has 60 square feet of area, name all the integer combinations that make up a possible length and width for that rectangle. Once again, if a rectangle has 60 square feet of area, name all the integer combinations that make up a possible length and width for that rectangle. Now, let's talk about this problem just a little bit here, all right? We've got 60 square feet. We got a nice rectangle here going. We got length and width. And by the way, we can interchange length and width. This rectangle could get longer and it could get wider and all sorts of things. So again, it allows for some flexibility of this problem. There's not one answer, all right? There's quite a few actually. Notice it says name all of the integer combinations that make a possible width and length. Now, let's talk about it. What is area about? It's about length times width. So what we're looking for here, we are looking for, looks like the factors. Wow, all the factors. Let's see if that, I don't think this pen wants to work for us today, guys and ladies. Let's see, try another one. Yeah, there we go. So we're basically looking for the factors of 60 and how to pair them together. All right, how to pair them together. Now, I want you to understand the way the picture's drawn is just probably for one setting. I mean, if you were going to do that. But these widths could shrink as the length gets longer, the width could get wider, and the length can get shorter, because it's all going to make a nice package in the middle. So let's talk about how we can get 60. Obviously, the easy ways. How about it? 1 and 60. 1 and 60 work together very well. That's one option. Well, 60 is even, so we can do 2. And how about 30? 2 and 30. There we go. Looking good. 3 will divide into there. 3 divides into 6 evenly, and 0 just goes along for the ride. So how about it? We can use 3 and 20. My goodness, already. This, oh, by the way, remember now, this could be the length, this could be the width. So we've got really 2 ways that can go, all right? But we're just going to go as we have it. From here, let's get closer. Well, 4, does 4 divide into 60? We always wonder about that one. Some people leave that one out. You just got the word from me, right, that it does. It works with 15, 4 and 15. Whew. 5. Well, it ends with 0, so 5 will divide in there evenly. How about it? 5 and 12. And while we're at it, one more option. I see a 0. I know 10 is going to work. How about it? 6 and 10. So these are pairs for length and width, but they also could work as width and length. All right, so again, there are your possible combinations. Which one? I always wonder questions like this, if you would understand. I hope you will. To get that area, which of these would be a minimum, make a minimum perimeter? In other words, would make the smallest perimeter. Well, if we look at these numbers and add them together, 1 and 60 is 61. 2 and 30 is 32. This makes 23. Notice they're getting smaller as we go. You say, well, Ernie, what does that have to do with perimeter? Because if we add those, that's half of the perimeter. So example, 4 and 15 gives us 19. That's half the perimeter. The perimeter will be 38. So which would make a minimum perimeter? I'm going a little bit off the dark edge today here, right? Dark side, so to speak. Those of you who want the force to be with us. And 16 and 16, that would make 32. That would be the smallest perimeter if we keep it integer values. Integers, by the way, whole numbers. So we don't have any fractions. We're not going to say a half times 120 here, although that would give you an area of 60. By the way, these are feet. 1 foot, 60 feet, 2 feet, 30 feet, and so forth. And if you multiply them, you get square feet. And also, if you multiply any of these, you get 60. So there's your problem of the day. Get you thinking a little bit outside the box a little bit here. And that we did say what would be a minimum perimeter if we were to take the distance all the way around here. Well, it would be basically the ones where the length and the width seem to be the closest together. And that's the way we would go with that.